Here we go, scholars, with the tree trunk problem from your notes paper. Two things. So one, I didn't remember when I put this problem on your paper. I love this problem so much. That you actually need the answer to part A in order to answer part B, which is what's on your paper. And you don't actually know how to do part A until after you learn about integrals, which is coming up after Thanksgiving break. So here's a quick preview, and we'll give you the answer to part A so that we can go on and answer part B. If I know how fast the radius of this tree trunk is changing, and I know that right now the tree trunk times 0, the tree trunk's radius is 6, I can use what's called an integral. Essentially, it's a big underivative, an antiderivative, to figure out how long the radius is after 3 years. And I could probably recognize R of 3 means the radius of the tree trunk when time equals 3 years. So here's what you need to know, that when time is 3 years, the radius of the tree trunk is 6.6108047 centimeters. The other thing I should tell you before we start is that this is a calculator problem, so you can feel free to use your calculator while we move on to answer part B. So here's the related rates part of this problem. You can probably understand that as the radius of the tree trunk grows, the area of the tree trunk, if you cut off the top and you just look at the circle area that was left, the area there is increasing. So this is what we've been asked to find. Find the rate at which the area of the face of the tree trunk, after you cut off the tree, is increasing at time t equals 3 years. And up in the top of the problem, we've been told that that area is circular. So we know dr dt, that was given, and we seek what we're going to call dA dt, the rate of change of the area of the cross-section of the tree trunk. And we want that rate of change at the exact moment when time equals 3 years. So I need an equation that's going to relate R, and A. So you know the area of a circle is pi r squared. Now I'm going to take the derivative of both sides with respect to time. So dA dt is pi. Now I have the derivative of r squared with respect to time is 2r times dr dt. The thing I've been asked to find is the derivative of, the derivative of the area with respect to time, the rate of change of the area with respect to time at the exact moment that t equals 3. Remember this notation, it comes in very handy here. So that's going to be pi times 2 times r. R is changing, but once I know I'm going to let time equal 3, I want specifically that time from the radius from part A, which is 6.61087 times what is the rate of change of the radius at exactly time equals 3. So we're going to have to take a minute out here. We're going to find dr dt when t equals 3. Use your calculator. So when I plugged t equals 3 into the expression I was given for dr dt, I got that the radius is changing at 0.21326 centimeters per year when time is 3 years. So I plug that in here. Now I'm just going to evaluate this expression. Again, this is the calculator section. Feel free to use your calculator. So I did that multiplying on my calculator, and I get this final answer. The rate of change of the the rate of change of the area of the cross-section of the tree trunk when time is 3 years is 8.858 centimeters squared per year. So just double check the units there. This is an expression for dA dt. A is area, so it should have length units squared. Time is measured in years, so that's how I get my units, centimeters squared per year.